everyone, hope everyone is safe and sound and staying at home. I'm Arita Haque and I'm once again back on our listener day with another physics lesson. And today is the second video on heat. So without any further delay, let's just get started. So in the previous video, we discussed about the basics, the very basics about heat. So now we will dig a little deeper into it. So we will start off with what is specific heat capacity. So as you can see, I've written two different materials of the same mass will undergo different temperature changes despite having the same total energy added due to differences in a quantity called specific heat capacity. Specific heat capacity is dependent on the material in question, and you will typically look up the value of a material specific heat capacity in a table. More formally, specific heat capacity is defined as the amount of heat energy that must be added per unit mass in order to raise the temperature by a degree Celsius. The SI units for specific heat capacity, usually denoted by C, are J and kgK. So think about it like this. Suppose you have two different substances that weigh exactly the same and are at exactly the same temperature. So the first substance has a high specific heat capacity and the second substance has a low specific heat capacity. Now suppose you add exactly the same amount of heat energy to both of them. The first substance, the one with the higher heat capacity, will not go up as much in temperature as the second object. So now we will be moving on to some factors that affect the temperature change. So there are many such factors that affect how the temperature of a substance will change when a given amount of heat energy is transferred to it. These factors include the mass of the material. As I mentioned earlier, a smaller mass will undergo a greater temperature change for a given amount of heat added, and the specific heat capacity C. So if there is a heat source supplying power, which is denoted by P, the total heat added depends on the power P and time, which is denoted by T. That is, the heat energy, which is denoted by Q, will equal to power into time, which is P into T. I'm repeating, the heat energy, which is denoted as Q, will equal to power into time, which is P into T. So the rate of temperature change is another very interesting factor to consider. So there's a very important question which says, do objects change their temperature at a constant rate? It turns out that the rate of change depends on the temperature difference between the object and its surroundings. Newton's law of cooling describes this change. The closer an object is to the surrounding temperature, the slower it approaches equilibrium. Now we will be talking about temperature changes and phase changes. So the formula that relates the change in temperature to an object's mass, specific heat capacity, and heat energy added or removed is as follows, which says Q is equal to mc delta T. So the heat capacity and the specific heat are related by C, which is equal to Cm, or C equals to C by M. So the mass, which is M, and the specific heat, which is C, and the change in temperature, which is delta T, and heat, which is the Q, are related by the equation Q is equal to mc delta T. So values of specific heat are dependent on the properties and phase of a given substance. Similarly, a quantity called the latent heat of fusion, denoted as LF, describes how much heat energy per unit mass is required to change a substance from solid to a liquid. Just as with specific heat capacity, its value also depends on the physical properties of the material in question and is often looked up in tables. So the equation which relates heat energy, which is denoted by Q, to the mass of the material M and the latent heat of fusion is Q is equal to mLF. In here, Q is denoted as the heat energy and M is denoted as the mass, and LF is denoted as the latent heat of fusion. Thank you so much everyone for watching today's video. I really hope you enjoyed it, and I really hope we had fun learning in this video. So see you in the next video. Have a good day. Bye.